morning, everyone. My name is Sumaiya and today I am going to discuss computer networking. Let's begin with it. Here is some contents about computer networking and introduction to computer networking, then learning objects. Thank you for being here. By the end of this discussion, we will have a solid foundation in computer networking. Especially, we will be able to clarify, define what a network is, articulate the advantage and challenges that come with it, distinguish between different network types and topologies, explain the layers and fundamental TCP IP model, identify key networking devices, and understand the impact of future trends like AI and 5G. This will provide an essential framework for understanding the technology that powers our modern world. Okay, now what is computer networking? At its core, a computer network is simply a collection of interconnected devices that can communicate with each other to share resources and data. It turns isolated computers into a powerful collaborative system. Think of it like this: a single computer is a powerful tool, but a network of computers is a superpower. It's the difference between working alone in a room and being part of a global team. From sending an email to streaming a movie, it's all made possible by networks. Next is advantages of networking. The benefits are truly transformative. Let's break them down. Resourcing sharing. Imagine an office where every computer needs its own printer. It's costly and inefficient. A network allows one high quality printer to serve an entire department, significantly reducing cost. Enhanced communication. This is the most obvious advantage. Email instant messaging and video conferencing tools like Teams or Zoom have how to work and connect, collapsing geographical barriers. Centralized data management. Instead of having important files scattered across individual computers, they can be stored on a central server. This makes backup, security, and collaboration initially easier. Cost reduction. By sharing hardware like printers and servers and software license, businesses can achieve sustainable savings. It also reduces IT management time and cost. 5. Disadvantage of networking. However, we must also acknowledge the challenges that comes with the connectivity. Security risk. This is the biggest challenge. Connecting devices creates points of entry for malicious actors. A network is only as strong as its security link. Management capability. A network requires specialized knowledge. As networks grow, they become more complex to manage, monitor, and troubleshoot. Network wide features. If a critical server or a central network device fails, it can bring down operation for an entire organization. Types of networks. Networks are primarily categorized by their geographical scale. We will explore the personal, the local, and the global. Personal area network. Okay, personal area network. This is your immediate digital bubble. A pen connects devices within personal space, typically within a range of 10 meters, via wireless technologies like Bluetooth or NFC. The most common example is wireless earbud paired to our phone. When we wirelessly send a photo from your phone to laptop, it's all about connecting the devices on around local area network. The LAN is workhouse of offices, schools and homes. It connects devices within a limited geographical area like a single building or a campus. If you have ever connected to Wi-Fi at work or school, you have joined a LAN. These networks are typically privately owned and managed. They allow for fast and secure communication between devices within that location, like accessing a shared folder on a server or printing to a network printer. Wide area network. Now let's think bigger. A WAN spans a large geographical area, a city, a country, or even the entire globe. The most famous one is the internet itself. A WAN is essentially a network of networks. It connects multiple lanes together. When your office LAN is in New York needs to communicate with a branch office LAN in London, it does so over a WAN, often using instructive list from telecommunications companies. TCP, to manage the immense complexity of network communication, we use layered models. The TCP IP model is the practical real world blueprint of the internet. It structures all communication into four distinct layers, each with a very specific and critical role. Think of it building a house. We have a foundation, a frame, walls, and then the interior decor. Each layer depends on the below it. Application layer. This is the layer we interact with directly. It provides network services to user applications like web browsers, email clients, and transfer programs. Browsers protocols like HTTP for web browsing, FTP for file transfers, and SMTP for email all operate here. When you type a website address into browser, you are initiating a process at the application layer. Transport layer. Think of this as the postal service of the network. Its job is to ensure complete and reliable data transfers between applications on different devices. The two key protocols here are TCP and UDP. TCP is like sending a registered letter. It's reliable, requires acknowledgement of delivery, and is used for things like web pages and emails where accuracy is critical. UDP is like sending a regular postcard. It's faster, best effort, and doesn't require acknowledgement. Internet layer. This layer is all about logical addressing and routing. It takes data from transport layer and packages into pockets and assigns source and destination IP addresses. Its primary job is to find the best path across the network to get these packets to the destination device, navigating through various routers and networks. The Internet Protocol IP is the star of this layer. Network access layer. This is the physical groundwork of the model. It defines how data is physically transmitted onto the network medium, be it Ethernet cable, fiber optics, or Wi-Fi signals. It deals with physical addresses, MAC addresses, and translate logical IP addresses into hardware addresses that devices on the same local network can understand. Network topologies. The topology defines the physical or logical layout of how devices are interconnected on a network. Each design has unique advantages and trade-offs relating to cost, performance, and reliability. Bus topology, an older design where all devices are connected to a single central cable called the bus. It's simple and cheap to install. However, it has a critical weakness. If the main cable falls, the entire network goes down. Furthermore, network performance can degrade significantly as more devices are added. As they all share the same communication line, it's largely obsolete in modern networks. Star topology. This is the most common layout you will see today. In a star topology, all devices connect to a central node, like a switch or hub. Its key advantage is fault isolation. If one cable fails, only that single device is affected. The rest of the network remains operational. It's also easy to add new devices without disrupting the network. The downside is that the central device becomes a single point of failure. If the switch dies, the whole network goes down. Ring topology. Here devices are connected in closed to ring. Data travels in one direction, passing through each device until it reaches its destination. It's an orderly network where performance is somewhat predictable. However, it can be easily disrupted by a single failure in the ring or at any device. If one device or cable fails, the entire loop is broken. Modern ring networks often have dual rings for redundancy to overcome the weakness. Mesh topology. This topology offers the ultimate in redundancy and reliability. Devices are interconnected with many redundant paths between them. If one path fails, data is automatically rerouted through another available path. These are two types: a full mesh where every device is connected to every other device, very expensive, and a partial mesh which is more common. You see this in wireless mesh networks for entire cities or in critical infrastructure where downtime is not an option. Network hardware versus software. It's important to understand that a network is a combination of both physical hardware you can touch, like routers, cables, and switches, and software you can't, like protocols and services that govern communication. Both are equally important. The hardware is the body, and the software protocols are the brain and nervous system. One cannot function without the other. Network devices. Now let's meet the Key players, the hardware devices that make networking possible. Router. The router is the intelligent director of traffic. Its primary job is to connect data packets between them. It makes decisions based on IP addresses. Think of your home router. It connects your personal homeland to the past one of your internet service provider, and then to the internet. It routes traffic from your laptop to Netflix servers and back again. Switch. This switch is the efficient connector within a single lane. It's more intelligent than a hub. It learns the MAC addresses of devices connected to it and forwards data frames only to the specific port where the destination device is located. This makes LAN communication highly efficient and secure. As traffic isn't broadcast to everyone, they are the foundation of modern wired network. Hub. A hub is which is less intelligent processor. It's a simple device that makes data coming in from one port and broadcast it out every port. This port and broadcasts it out to every other port. This creates unnecessary network traffic and security concerns. Access point. An access point allows wireless devices to connect to a wired network. It's what provides Wi-Fi coverage in your office or home. The AP connects to a wired switch via an Ethernet cable network and the wireless devices, translating between the wired and wireless. The firewall is the network essential security guard. It sits at the boundary between different networks, typically between a trusted internal network and an untrusted external network like the internet. It scrutinizes all incoming and outgoing traffic based on a set of predefined security rules, blocking malicious activity and unauthorized access while allowing legitimate communication to pass through. Network protocols. If devices are the hardware, protocols are the rules and languages that they use to communicate. Let's look at the different languages used for different tasks. Web protocols. HTTP and HTTPS are the protocols of the World Wide Web. They define how web browsers and servers communicate. The critical difference is the S in HTTPS, which stands for secure. HTTPS adds a crucial layer of encryption to protect the data being exchanged from airdroppers. Always look for HTTPS in your browser's address bar, especially when entering sensitive information. File transfer protocols. FTP is standard protocol for transferring files between computers over a network. TFTP is a simpler, stripped down version that's often used for booting diskless workstations or transferring configuration files to network devices like routers and switches. Email protocols. Email relies on a set of protocols. SMTP is used for sending mail, For receiving mail, you have two main options, POP3 and IMAP. POP3 downloads emails to your local device and typically deletes them from the server. IMAP, on the other hand, keeps your mail synchronized and stored on the server, allowing you to access the same inbox from multiple devices. Network transport network protocols. As we saw earlier, TCP provides reliable, connection oriented communication, ensuring data arrives complete in order. UDP provides fast, connectionless, best effort delivery, sacrificing reliability for speed. Network and link layer protocols. IP is the fundamental protocol of the internet layer, responsible for addressing and routing. At the network access layer, Ethernet is the dominant protocol for wired networks, defining how data is formatted and transmitted over cables. For wireless, the IEEE 802.11 family of standards, which we commonly call Wi-Fi, defines the rules of wireless communication. Office network design. Designing an office requires carefully balancing several key factors. Performance. Will the network be best enough for application users? Yes. Security, scalability, cost. Office network diagram. Let's bring it all together with a typical office network. You can now the router connects to the internet. Traffic immediately hits the firewall, which filters it. The clean traffic passes to the core switch, which connects all the wired devices, desktops, servers, and other switches. The wireless access points also connect to the switch, providing Wi-Fi coverage. Critical services like DHCP for assigning IP addresses and file storage run on dedicated servers. The layered design provides both performance and security. Cisco network simulation. Tools like Cisco Packet Tracer are individual for learning and planning. They allows us to design, configure, and troubleshoot virtual networks. Without needing physical hardware, we can build complex networks, see how traffic flows, and test configurations in a safe, risk-free environment before implementing them in the real world. DHCP configuration. Dynamic Host Configuration Protocol automates one of the most critical yet tedious network tasks, assigning IP addresses to devices. Without DHCP, a network administrator would have a manually configure a unique IP address on every single device, a nightmare in a large organization. DHCP eliminates this need and prevents configuration errors. Benefits of DHCP. The benefits are clear. Centralized management. IP addresses are managed from a single point. Reduced errors, efficient IP addresses reuse. NET. Network addresses translation is a clever technology that conserves the limited number of available public IPv4 addresses. It allows an entire office or home network to use private IP addresses internally while appearing as a single public IP address to the internet. This provides a layer of privacy and security as internet addresses are hidden from the outside world. Static net. Static net creates a one-to-one like web or email server inside your private network and make it accessible from the internet. Dynamic net. Dynamic net maps private IP addresses to a pool of public IP addresses. It's a many to many relationship. It's more efficient than static net but still requires a public IP address for its simultaneous connections happening from inside the work. PAT, port address translation. This is the most common form, often what people mean by the say net pad or overloading. It allows the share single public address. It does this by using unique source node numbers to track each connection. This is exactly what happens in your home router. Cloud computing and networking integrates cloud services with network systems. It enables virtualized and scalable networks. Cybersecurity in networking protects against hacking, malware, and data theft. It uses encryption, firewalls, and intrusion detection. IoT in networking connects smart devices and sensors to the internet. It brings new opportunities and security challenges. 5G and future networks provides ultra-fast connectivity and low latency. It supports advanced applications like AR and VR. AI in networking automates network management using artificial intelligence. It helps in predictive maintenance and fault detection. Real life applications of networking: banking, online transactions and secure system, healthcare, telemedicine and patients data sharing, education, online classes and virtual campuses. Case study: Office network implementation, analyzing requirements of the office, designing the network layout, deploying and testing the system. Summary: reviewed basics, advantages, and types of networks, explored devices, protocols, and topologies, discussed advanced topics like DHCP and 5G IoT. Thank you. If you have any question regarding this topic, computer networking, let me know in the comment section. Thank you all.